Hey everyone, welcome back. We're going to start with chapter 6, and chapter 6 is all about polygons. And so we're going to talk about generic polygons first, and then we're going to talk about the specific um, types of polygons and how we can find area and angles and all those different things. So this is going to be 6.1, and we're going to specifically talk about angles of polygons of all different sizes. So first, we have to talk about diagonals. So here we've got a picture of a polygon XYZ W, and we're going to describe how we draw polygons. Basically, it's just a segment, or sorry, not describe how I draw polygons, but by drawing diagonals. So we have to draw a segment, and it is a segment between two non-consecutive vertices, and that's really important that non-consecutive means they are not side by side. So if you notice here, we have segment XZ, and these two angles are not side by side, so that's why we can connect them. And in this case, starting at X, this is the only diagonal that we can draw because W and Y are both next to angle X. So in this case, a four-sided figure is only got one diagonal in it. Okay, and if I ask you to list all the diagonals, you would just write them as a segment, just like we've always written a segment with the two capital letters and then the dash above the top. So here are a couple examples of different figures with different diagonals. So we've got a triangle, quadrilateral, pentagon, and a hexagon. You are going to want to know what those words mean in terms of how many sides they have. So in a triangle, if you look at this, if we pick one angle, what you should notice is that the other two angles are already next to it. So in a triangle, there are no diagonals. You can't draw any from one angle to another without it being side by side. So in a quadrilateral, okay, this is just another example of a quadrilateral. We can only have one diagonal. Okay, so from one angle across to one that's not next to it. A pentagon has 5 sides, and in a pentagon, if we pick an angle, okay, we can draw 2 diagonals. Notice that the ones that we start at go across to 2 that are not next to it. And then a hexagon, which has 6 sides, we can draw 3. So what you should notice is that the more sides we add to the shape, the more diagonals we get. Okay, and this is going to be really important. And what you should also notice is that every time we draw on a diagonal, more and more triangles are created in the shape. And it's important to remember that in a triangle, one triangle, the angles add up to 180. That's something you guys learned last semester, and hopefully you guys remember, because this is the concept that we're going to use to figure out the total number of degrees in a shape other than a triangle. So if you look, I just kind of took that information from the pictures and made it into a table here. I've got what the polygon is, the number of sides it has, the number of triangles that were created by drawing a diagonal, and then total the number of degrees. So what you should notice for the triangle is that there's 3 sides. We had only one triangle inside the shape because there are no diagonals, and our total was 180 degrees. A 4-sided figure had 2 triangles in it because we had one diagonal drawn. Okay, so all I did was take 2 times 180 because there's 2 triangles. So that gets me a total of 360. And the same process keeps going. So for the pentagon, there's 5 sides, so 3 triangles created by the 2 diagonals. So 3 times 180 is 540. And what you should notice is that the pattern and the formula that you're going to want to write down here is that you take the number of sides minus 2 times 180. That's going to tell you the degrees of the interior angles of the shape. So this formula right at the bottom, you definitely want to make sure that you write that down. So we're just going to use this to go through a couple examples in looking at these figures. So the first one is a nonagon. Well, if you don't remember what a nonagon is, it's a side or a figure that has 9 sides. So all I'm going to do is take my formula n minus 2 times 180 and just plug in the number of sides. So n minus 2 times 180, in this case 9 minus 2 times 180, gets you 7 times 180, which is 1260. So this is 1,260 degrees inside a 9-sided figure. Same concept for this one. Now this one, you're not just finding the degree total inside the shape. You have to use that, though, in order to set up your formula. So here we've got a 4-sided figure, which means that it's going to have a total of 360 degrees. And if you weren't sure, you could use your formula where we take 4 minus 2 times 180, and that gets us 360. Well, what they want in this problem is for you to find the measure of each interior angle of the parallelogram. So not only you're going to have to find x, but you're also going to have to take x and plug it back in. So first we're going to find x by setting up a formula. Well, we already said that the total here is going to be 360 degrees. So all I'm going to do is add up every single angle and set it equal to 360. All right, so I have equations set up here, and then we're just going to combine like terms. So when I combine, I get 360 equals 32x plus 8. So remember, this is just combining all the x's together, and then the 4 plus the 4. And then it's just solving for x, which you guys should all be able to do. So I subtract 8 over to the other side, and then if last I would divide by 32. So I get x is 11, but this is not the degree measure, this is just the variable. So remember to read your directions. If it wants the angle measures in the shape, you need to plug x back in. And that's exactly what we did. So in step 2, we are plugging in all of our angle measures here, and we get that angle R is 55 degrees, angle S is 125 degrees, angle T is 55, and angle U is 125. Okay, they have both the same formulas, so when you plug them in, you should get the same numbers. If you don't, make sure you double check your math. Right? So there's your 4 angle measures that they were looking for. So please make sure in any of these problems, the math's not hard. You just have to make sure that you're reading what they're asking for. Do they want x? Do they want the angle measures? Or do they just want an equation? Make sure you read. Okay. So this one, I want you to do the same thing. It says find the measure of each interior angle of a regular octagon. So they want just what one measure is, not the total. Okay, so that's also important that you read those. So here in an octagon, we have 8 sides. So we could plug into our formula. We know that 8 minus 2 is 6. 6 times 180 gets us 1080. So total, those angles all add up to 1080 degrees. Well, we know that there's 8 angles, so 8 times the number of angles has to be 1080 degrees. So all we have to do is just divide by 8. That gets us 135. And now the important thing for this one, and why I didn't have to add up a whole bunch of things, is because in this picture they have all the angles marked as congruent. All right, that's what those arcs all mean. So all I'm just calling each of these is x. X plus x plus x plus x all the way up until I add all 8 of them. And that's where I get the 8x. All right, and of course that 1080, this is from the very first example where we plugged into the formula n minus 2 times 180. So one angle in this shape is 135 degrees. All right, now this one gives you the opposite. This time it says the measure of an interior angle of a regular polygon is 150. Find the number of sides. Well, already you can see at the bottom the polygon has 12 sides, but how would we know that? In this case, we're kind of working backwards. So we're looking for the number of sides, all right? And we know that in the formula, 180 times the number of sides minus 2 equals the total. Well, in this case, the total is 150 times the number of sides because we know that one angle is 150. So we're just replacing the total measurement with 150 times the number of sides, which we don't know yet. So 150n. All right, so we're just replacing the s with 150 times the number of sides. And then this is just a matter of solving for n. So what I would go ahead and do is distribute the 180 all the way across. So we get 150n equals 180n minus 360. And then I'm just going to solve for n. So I subtracted 150 over and then added the 360 over. And I just did this to keep everything positive. There's multiple ways you could have done this. And then lastly, divide by 30. So there's where we get our 12. All right. So if you're given a measure of one angle, but you want to find the number of sides, you're going to be looking for n. Don't plug n in for don't plug 150 in for n. Leave it as a variable and solve for it. All right, now the last major section of this beginning of the chapter is the exterior angles. And just like we know in a triangle it always equaled 180, well, this is going to be one rule you're always going to want to know. It's that the exterior angles of any shape, okay, are always going to add up to 360. Doesn't matter how many sides there are, it will always add up to 360. So make sure you underline that in your notes, highlight it, whatever you need, so you don't forget that the exterior angles are equal to 360. And remember, exterior angles are formed by extending the sides. It's something you definitely had to know for the first semester final. Okay, so if we look at this diagram right here, it looks really crazy because there's a lot of lines, a lot of equations. All we're doing is finding what the value of x is in this picture. Well, what you notice is that we don't have any measurements to fill in. We just have a bunch of equations. But these are all exterior angles to this shape. And we just learned that the total of all the exteriors in a shape is going to be equal to 360. So what we're going to do is just write an equation by adding all of those equations up and setting them equal to 360. And I'll go back so you can have those equations. Oops, maybe. Nope, I'll just leave them there. Okay, so there's all of our equations. We're adding them all up. I know this one's kind of long. Equal to 360 always for exterior. And then it's just a matter of combining like terms. When we combine, you get 31x minus 12 equals 360. And then we can solve for x, which I did here. So we get that x is equal to 12. And that's all that this one wanted. It didn't want you to find the measures of the individual angles. But if it asked for it, of course, you would just plug x back into whatever it's asking for. So that's it for this section. I know I went through that pretty quickly. Just the key parts you got to make sure you have down are what a diagonal is, what the formula here that I have highlighted, okay, and then how we can find the number of sides, an angle measure, or the exterior angle, which was what our last example was here, by setting exterior angles always equal to 360. So if you have any questions, let me know. Otherwise, you guys are good to work on your packet. Thanks for listening.